So let's focus on the different models of fractions. Students need to see and experience fractions in different ways. And so they should have familiarity with all three of these models. I'm going to introduce them pretty quickly, but knowing within intensive intervention, you'll probably introduce one model, practice that for several days or even several weeks. Then you might introduce another model and then practice that model. So while we're going to go quickly so that you gain all of this information, just remember that you would introduce this information a little bit more slowly to students. So the first model that we're going to focus on today is the length model of fractions. And how I'm going to do this is I'm going to show the representation of these fractions, and then I'm going to go over to my table and I'm going to show the concrete representation of these fractions. So how you can show these different representations using the concrete and the representational. And I also have the abstract right here. Remember, we always want to be showing the abstract form of our number so that students understand how all of this works together. So let's focus first on the fraction 2/3. I'm going to show this with fraction bars or tiles. That's a pretty common representation to use with the length model of fractions. So the first thing when I'm thinking about my fraction, I have my fraction 2/3. And when I'm going to represent fractions, either pictorially or representationally, or with the manipulatives, which I'll do in just a minute, I always want to focus on the denominator first. So here my denominator is 3. That tells me that I have a whole, and that whole is broken into 3 equal parts. I have those equal parts here, 1, 2, and 3. Now I focus on my numerator. My numerator is 2. So that means I'm going to show 2 of those 3 equal parts. So I'm going to take that one away to show the fraction 2/3. Now you might be asking yourself, why is this the length model of fractions? Well, this is the length model of fractions because I can envision this representation as falling on a number line where here is 0 and over here would be 1 right there. And so then I can see that the value of 2/3 falls somewhere between 0 and 1. I can see that the 2/3 is not greater than 1. I see that it's less than 1. And if I have an understanding of where 1/2 is, which would be right about there, I can also see that 2/3 is greater than 1/2. So this length model of fractions allows me to understand the magnitude of the fraction, or the fraction's value. So this is what it would look like with the representational. I'm now going to move over here and show you what it's going to look like with the concrete. So here I have my whole. I'm going to do the same fraction, 2/3. I'm going to show my whole right there. And I understand that that whole has a denominator and it's broken into 3 equal parts. So I'm going to show those 3 parts. Now I can do this 2 ways. I can show my parts right here, like basically on top of the whole. I could also put the parts literally on top of the whole to show that that whole can be broken into 1, 2, 3 equal parts. Now I'm not done here because I want to show the fraction 2/3, which means I need to show 2 of those 3 parts. So here is the fraction 2/3. I'm showing 2 of the 3 parts. I could also show it like this. Here are 2 of the 3 parts. Remember, this shows the length model of fractions because we have 0 over here and 1 here. And I could think about this as just a continuous number line where I could actually show fractions greater than 1 in this space over here. Now I do want to show one thing that I have seen some teachers do that is really a no-no. And that is to show the fraction 2/3 in this way, all right? If I show 2/3 in this way, it does not match the abstract form of the number. And in fact, to me, this looks maybe like 3/2, maybe like some other fraction. When I show 2/3 this way, I see the numerator on top and the denominator on bottom. Or if I show 2/3 this way, the numerator is on top and the denominator is on bottom. If I do it this way, it's not following that convention. So this is a non-example. We would want to do something like this or like this for the fraction 2/3. Now these are fraction tiles or fraction bars. Lots of schools have these, lots of classrooms have these, so you might have access to these. And they're a really good manipulative to use to help students understand the length model of fractions. But we have some other options as well. So I want to look at another manipulative. These are called Cuisenaire rods. Your school might have these. Often they're used in the younger grades for counting. That's mostly where we will see them. You might use them for addition and subtraction, but we can also use them for fractions. And these Cuisenaire rods have a little bit of an advantage excuse me, over the fraction bars or fraction tiles, and I'm going to talk about that in a minute. So I'm going to go back to my fraction 2/3. So remember, when I'm talking to students about showing a fraction, I'm not going to focus on the numerator first. I'm going to focus on the denominator first. So here I have a whole, and that whole is broken into 3 parts. So I'm going to find a whole, all right, and I've still got my length model. Here I've got my 0, and over here this represents 1. And then I'm going to break that whole into 3 equal parts and show 2 of those parts. So here is the fraction 2/3. Now with the Cuisenaire rods, the nice thing about them is there's not just one way to show a fraction, but there are actually several different ways. So here is a whole. There's my 0 and 1, just to help you remember that. Here is a whole, and then I can show 2/3 of that whole. Here's 0, and here's 1, and this also represents the length model of fractions. Now the nice thing with the Cuisenaire rods is that students really have to figure out how to take this whole and break it into those equal parts. And not all wholes can be broken into the same number of equal parts. So for example, this blue rod, it would be very hard to break this into 4 equal parts, but it works very well breaking it into 3 equal parts. But here are 2 representations, and now I'll show us what it'll look like with our Cuisenaire rods. So take my fraction tiles away. And now I'm going to get out my Cuisenaire rods. So here is a whole, and I could do the whole thing where I have to experiment. I can take that whole and break it into 3 equal parts, and I'm going to show 2 of those 3 parts. But I could also take this whole and break it into 3 equal parts and show 2 of those parts. And I can get crazy today. I can show this whole and break it into 3 equal parts and show 2 of those parts. So what we've done here is we've made multiple representations of the same fraction. Now when we have the fraction bar, I'll put it up here to help us remember the fraction bar, and then I'll slide it down so we can all see it there. When I have the fraction bar, I only have one option. I have my whole, it is always this long, and when I'm thinking about thirds, they are always these pieces, they're always orange, and most likely they are also labeled with 1/3. So that's helpful for understanding fractions, but it's not really challenging students in terms of good fraction understanding. But let's look at the Cuisenaire rods. I can take this blue whole and break it into 3 equal parts. I can take this lime green whole and break it into 3 equal parts. And I can take this dark green whole and break it into 3 equal parts to show 2/3. So with the Cuisenaire rods, you often have many different ways to show the same fraction. And students really have to think about that denominator and think about the equal parts of the denominator in order to be able to show the fraction. So the Cuisenaire rods give you a much more flexible model for showing fractions. They are still the length model because I consider the left side of my whole 0 and the right side of my whole 1. So 0, 1, 0, 1. But my whole isn't always this long, and it's not always red. I'm really having to think about what the fraction is and how to represent that fraction. So now we're going to look at the next model of fractions. So we're going to think, there's our length model of fractions. Oh, we're not going to look at the next model of fractions. I have another representation to show you. I've got the number line. So it's talking about the fraction tiles and talking about the Cuisenaire rods and how those represent basically a number line that we can place the fraction on. And we should also use number lines. When students can place fractions on number lines, it shows a very expert understanding of the fraction. So here's my number line. On this number line, this represents 0, and here I've got 1. I can break this number line into equal parts. So I have 1, 2, 3 equal parts, and to show 2/3, it would fall here on the number line. So again, I can see that 2/3 is less than 1, 2/3 is greater than 0, and if I understand the benchmark fraction of 1/2, I can see that 2/3 is greater than 1/2. So with this length model of fractions, we're always helping students really understand the magnitude of the fractions. So I showed fraction tiles, or you might call them fraction bars. We also looked at Cuisenaire rods, and we also talked about the importance of number lines. So when you're introducing fractions to students or helping students practice fraction concepts, make sure that they understand fractions as appropriated by length.